Well, we talk about simple interest, we talk about compounded n times a year. Now we want to talk about continuous compounding. Okay? So, some banks they use continuous compounding. It's like the compounding period increases, infinitely. Well, it's like, for example, for compounded n times a year, we said that they calculate your interest n times a year. Now imagine this n increases, right? They calculate your interest every second like that, okay? Every moment they are calculating your interest on your principal and accumulated interest. In this case, we have continuous compounding, okay? Well, uh, compounded n times a year, the equation is presented here. Now imagine n goes to infinity, right? Increases. Well, then we have this equation for continuous compounding. That's your principal times e. E is an irrational number. Okay, here we go. E to the power of r times t, right? So we talk about irrational numbers when we were talking about, number theory. We said that we can have terminating decimals, we can have repeating decimals, but for irrational numbers, the decimals never end, okay? It's not terminating, it's not repeating, right? So here we go. This is the equation that we have for continuous compounding, okay? Well, in your textbook, actually it's explaining where E came from and how we came up with this equation. I leave it to you to read that section. And if you have any questions, then I can explain it to you, okay? We can arrange a time, office hours, and explain it to you, okay? So here's the equation that we have for continuous compounding. P principal times e to the power of RT. Okay, here we go. A is your future value, P your principal or present value, E is the irrational number to the power of R, interest rate times time period, right? Time period, okay. So one thing is that make sure that you have a calculator that has natural logarithm and it has the irrational number E, okay? So let's answer a question. You decide to invest $8,000 for 6 years. Okay, so we have the principal $8,000 for 6 years. For 6 years times 6 years. And you have a choice between two accounts. First one, okay, option 1 pays 7%, so R is 0.07 per year compounded monthly, okay, so N is equal to 12 compounded monthly. Second, okay, here is the second option, pays 6.85. Okay, change that into a decimal, so R is 0.0685. If you don't know, that's easy, just 6.85 divided by actually 100, so it's 0.0685. Okay, compounded continuously. Okay, this one is compounded continuously. Okay, here we go. Which is the better investment? Okay, so I find out the future value for both, and that's investment. Well, the option that gives me, a bigger future value is a better option, right? Okay, just plug in the values. Option 1, I know that future value is principal times 1 plus r over n to the power of nt. So future value is principal 8,000 times 1 plus r is 0.07 over n, which is 12. It's compounded monthly, okay, to the power of n, 12 times t, 6 years. So future value is 8,000 times 1 plus 0.07 over 12 to the power of, okay, 12 times 6 is actually 72. Guys, again, don't forget, first of all, you need to calculate 0.07 over 12. Okay, so I'm gonna use my calculator. Okay, so 0.07 divided by 12, whatever it is, add it to 1. Okay, whatever it is on my calculator, I add it to 1. Whatever the result is, okay, well, I calculated to the power of 72. So whatever the result is to the power of 72 gives me a number. Now I multiply that by 8,000 times 8,000. So I get something around 12,160.8. Here we go. That's the future value for option 1. Okay. Now for option 2, okay, here is the equation that we have. A is principal times e to the power of r times t. So future value for option 2 is equal to principal 8,000 times e to the power of r, which is 0.0685 times t, which is 6 years. Guys, be careful, be careful. First of all, you have to calculate this power. You have to, okay? So 0.0685 times 6, okay? Whatever the result is, then you calculate e to that power. Okay, make sure that you can calculate e to the power of, a number on your calculator. Okay, so here it is 8,000 times e to the power of 0.411. Whatever the result of this product is, okay, you calculate e to that result, to the power of that result. Okay. E to that power, the result, you multiply the result by 8,000. Okay, well, here I get something around $12,066.6. Here we go. Here's the first option. It gives you around $12,161, and second option gives you around $12,067. Okay, which one is better? Which one gives you more money? Well, this one, compounded monthly. Okay, so 7% compounded monthly is a better choice for you, right? It gives you more money. Here we go. Now another question. You decide to invest 5,000, okay? So 5,000 is your principal, $5,000 for 5 years. So time is 5 years, and you have a choice between 2 accounts. Okay. Sorry. First choice, it says pay 6%, so r is 0.06, compounded quarterly, so n is equal to 4. And second option, 6%, so r is 0.06, compounded continuously. Okay, continuously. Okay, which one is a better investment? I give you around 1 minute. Okay, go ahead. If you need more time, you can pause the video. Okay. Sorry about the noise. My cat's feeder rotated and I had to fill it up. Okay, so first option is compounded quarterly 4 times a year and is equal to 4. Interest is 6%. Well, I just use the equation for compounded n times a year and I just plug in the values, right? Second one is continuous. Here is the equation that we have. A is equal to P times E to the power of RT. So for the first option, okay, principal is 5,000 times 1 plus R is 0.06 over 4 to the power of n times t, which is 4 times 5, which is 20. So again, guys, please, first of all, you have to calculate this ratio, okay? You need to calculate 0.06 divided by 4. Whatever the answer is, add it to 1, okay? Then the result to the power of 20, okay? The whole bracket, the result to the power of 20, you calculate it, okay? So for example, here, 0.06 divided by 4, when I add it to 1, I have 1.015, okay? To the power of 20, I calculated to the power of 20. Whatever the result is, okay, the result is, I multiply that by 5,000 times 5,000. So I get something around 6,734.3 or 0.27. Okay, doesn't matter. Now, second option. A is equal to P, that's continuous, E to the power of R times T. So P is 5,000 times E to the power of R, 0.06 times 5. Okay, first of all, you need to calculate the power. Okay, so 0.06 times 5 is 0.3. Okay, so it's like we have A is equal to 5,000 times E to the power of 0.3. First of all, you need to find out this exponent, e to the power of 0.3. Okay, use your calculator, whatever it is, then you multiply the result by 5,000. So we get something around 6,749.3. Here we go. So which one is a better option? Second one gives you more money, right? So 6% per year compounded continuously is a better choice in this question, right? Gives you more money. Okay. So here is compounded n times a year, right? P is principal, A is your future value, right? So here we go. Well, what if you want to find the principal? Well, that's easy. You want to find principal, you want it by itself on one side of the equation. Just divide both sides of this equation by this bracket, okay? So then here is what we get for finding the principal. That's not something new, right? So you can solve that equation to find P, right? Here we go. For example, in this question, it says how much money should be deposited today? It's asking for the principal in an account that earns 6% compounded monthly so that it will accumulate to 20,000 in 5 years. So here you have the future value. Future value is 20,000. You have time, 5 years. You have R 0.06 and wants you to find the principal. Okay, so principal like that, okay, is future value over this bracket, because we know that future value is principal times 1 plus r over n to the power of nt. Now you want to find p, you divide both sides of the equation by this bracket, okay? You just plug in the values, okay? A is 20,000, 1 plus r is 0.06 over 12 to the power of n, which is 12. It says compounded monthly, so n is equal to 12, and times t, which is 5 years. Well, and you calculate it, right? So I want you, when you're reading the slides, calculate it. Well, let me know if you don't get a number close to this number, okay? So as you see, that's approximately. Well, if you invest around $14,827 today, after 5 years, you will have around 20,000 in your account. Now there is a concept, effective annual yield. Okay. Well, guys, let's say you go to a bank and, well, you say that you want to deposit a value, let's say P, okay? Principal, let's say $2,000, okay? And they offer you interest of, let's say 0.06, 6%, compounded, let's say semi-annually, okay? So semi-annually, so n is equal to 2, okay? After a period of 1 year, we want to see how much you get, okay? Let's calculate that. So future value is equal to principal times 1 plus r over n to the power of nt. So you want to deposit 2,000 times 1 plus 0.06 over n, which is 1 to the power of n, which is 1 times t, which is 1, right? Okay, so 0.06 over 1 is 0.06, so plus 1 is 1.06 to the power of 1 is 1.06 times 2,000. When you calculate it, you get $2,120. That's your future value. So if you go with compounded semi-annually, okay, so compounded semi-annually, if you put $2,000, after 1 year you will have 2,120 if the bank offers you a rate of 6%. Now, the question is that if I go with simple interest option, if I go with simple interest option and I put the same amount of money, I invest $2,000, okay, and I want to get exactly the same future value, 2,120 after 1 year. In that case, what is the simple interest rate? So, let's say you go to the bank, they offer you, something, let's say, continuous or compounded. Well, then you ask, if I go with simple interest option, I invest the same amount of money. After 1 year, I want to get the same amount of future value. In that case, what is the simple interest rate? We call that effective annual yield. So effective annual yield, or the effective rate, is the simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subject to compound interest at a stated rate. Okay? So, for example, here, you deposit $4,000, okay? That is your principal, $4,000, in an account that pays 8% interest. So your interest is 0.08, compounded monthly, okay? Compounded monthly, and is equal to 12. First of all, it says find the future value after 1 year, okay? After 1 year, let's find the future value, okay? We know that for compounded n times a year, future value is principal times 1 plus r over n to the power of nt. So future value is principal 4,000 times 1 plus r 0.08 over n is 12 to the power of n, 12 times t, which is 1. Okay, first of all, I find the ratio 0.08 over 12. Okay, so let's find out. Use your calculator. Okay, 0.08 over 12. Whatever it is, add it to 1. Okay, whatever the result is to the power of 12, the answer, multiply that by 4,000. So I get something around $4,332. Here we go. Now part B. It says use the future value equation for simple interest to find out the effective annual yield. Okay, I know that simple interest option, I know that in simple interest option, the future value is equal to principal times 1 plus RT. I want to get the same future value, so I plug in 4,332. Principal is the same, 4,000. T is 1 year. Then I can find R. The answer is the effective annual yield. Okay, so A is around 4,332 is equal to principal, which is 4,000 times 1 plus R. You want to find R times T, which is 1. Okay, R is your unknown. You want to find it. So you need to get rid of the numbers around it, right? So what I do, I divide both sides of that equation by 4,000. Okay, so I have 4,332 is equal to 4,000 times 1 plus R times 1 is R. I divide both sides of this equation by 4,000 because I want to have the unknown r by itself on one side of the equation. On the right side, 4,000, 4,000 cancel each other. That's exactly what I want. And on the left side, 4,332 divided by 4,000, well, it gives me 1.083. And on the right side, I have 1 plus r. I want to find r, so I add -1 to both sides. So r is equal to 1.083 minus 1, which is 0.083. Well, change it to percentage, r is 8.3%. We call that the effective annual yield, right? So I use the simple interest equation. R is my unknown, right? I just plug in the values. I solve that for r. Guys, use any methodology that you have to find r, okay? So, well, you're supposed to get similar number. So r is around 8.3%. Here we go. Well, let's say we don't have the principal, so you can't find the future value. How do you find the effective annual yield? So let's say we have an investment has a nominal interest rate r in decimal form and pays compound interest n times a year. Well, the effective annual yield in decimal form can be found by this equation. You can directly use this equation to find it. Okay? When you get the decimal form, okay, this equation gives you the decimal form, then you can change it to a percent, okay? So for example here, you have a passbook saving account, has a nominal rate of 5%, okay? So R is actually 0.05. The interest is compounded daily. So guys, when it says compounded daily, n is equal to 365, because of simplification, they want to simplify. It says just assume we have 360 days in a year. So n is 360. Even if you go with 365, that's right. So don't worry about that. The answer is going to be very, very close. So find the account's effective annual yield, and it says that, you know, the interest is compounded daily. Okay, so here's the equation that we have for effective annual yield. We want to find it directly, okay? So I just plug in the values. Y is equal to 1 plus r 0.05 over n 360 to the power of n 360 minus 1. Okay, again, don't forget, guys, first of all, you need to find this ratio. Whatever it is, add it to 1. Okay, so use your calculator. Okay, 0.05 divided by 360, whatever it is, added to 1. Well, the result to the power of 360, to the power of 360, you get a number. Okay, now subtract it. Okay, minus 1, calculate minus 1. Okay, we get something around 0.05. 513, yeah. Okay, if you want to change it to percentage, right, is 5.13%. Here we go. That's your decimal. You want to change it to percentage, you can multiply that by 100. So it's 5.13%, around 5% is the effective annual yield. Okay. Well, this effective annual yield, okay, is very important when you want to invest or you want to get a loan, okay? Well, that's a number that you need to actually pay attention to, okay? If you are for example, choosing what is the best option for you, okay? Well, if you're investing, choose the account that has a greater effective annual yield. If you want to get a loan, choose the account with the lowest effective annual yield, okay? So sometimes they call it annual percentage rate in the banks, okay? So that's the same thing, that's the effective annual yield. Well, let's say you deposit 5,000 in an account that pays 6% interest compounded daily. Okay? Find the future value after 1 year and use the future value equation for simple interest to determine the effective annual yield. Okay, in this question wants you to use the future value formula for simple interest. Okay, so first of all, you have the principal, $5,000, right? You have the interest rate 0.06 compounded daily. Okay, and you can go with 360 or you can go with 365. That's fine. Okay, you find the future value. Okay, you find the future value, and then in part B, okay, it says use the equation for simple interest. Well, the equation for simple interest is P times 1 plus RT to find R, the effective annual yield. Okay, so I give you around 1 minute. Go ahead, answer this question. If you need more time, you can pause the video. Okay, go ahead. Okay, so first of all, I find the future value. Okay, here's the equation for compounded and times a year. So future value is equal to principal 5,000 times 1 plus R, which is 0.06 over N, which is 365, or you can go with 360 to simplify, okay, to the power of N. 365 times T. T is 1 year, okay? T is 1 year. Here we go. This is after 1 year. So, first of all, I find this ratio, okay? So use your calculator. Go ahead. So 0.06 divided by 365, whatever it is, added to 1, okay, plus 1, and the result to the power of 365 to the power of 365. Well, whatever the answer is, now multiply that by 5,000, okay, times 5,000. Well, I get around $5,309. Now, part B, it says use the future value for simple interest to find out the effective annual yield. Okay, so sure. We wrote down the equation for simple interest. I want to find R. So future value is around 5,309. Principal is around 5,000 times 1 plus R times T, which is 1 year. Okay, so 5,309 is equal to 5,000 times 1 plus R. R is your unknown. You want to find it. You need to have it by itself on one side of the equation. So what I do, I divide both sides of the equation by 5,000. On the right side, 5,000, 5,000 cancel out each other. That's exactly what I want. So on the left side, so 5,309 over 5,000. So it's actually around 1.0618. On the right side, we have 1 plus R. Now you want to find R, add -1 to both sides, okay? So R is equal to 1.0618 minus 1, which is 0.0618. So change it to percentage. R is around 6.18%. That's your effective annual yield, right? Guys, you can follow any method that gives you R. So you're supposed to get something very close to what we have here, 6.18% or around 6.2%. That's the effective annual yield, okay? Here we go. Now here it says we have a saving account has a nominal rate of 7%. So we have R 0.07. The interest is compounded monthly. So okay, what happened? Okay, here. The interest is compounded monthly. So N is equal to 12. Okay, find the account's effective annual yield. You don't have the principal, you cannot find the future value, so you can actually find the effective annual yield directly using this equation. Just plug in the values. I give you around 30 seconds to answer this. Okay, go ahead, plug in the values and find the effective annual yield. Okay, if you need more time, please pause the video. Let's just plug in the values. R is 0.07 over n12 to the power of 12 minus 1. Again, first of all, you need to calculate this ratio, okay? So 0.07 divided by 12. Whatever the answer is, added to 1 here, and then calculate to the power of 12, okay? Then whatever the result is, minus 1. Okay, you get something around 0.072. So change that to percentage. The effective annual yield is around 7.2%. Okay, well, I'm gonna give you a break here and then we come back to answer this question. Okay.